Live from Brooklyn, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Lady Ada the Engineer, with me, Mr. Lady Ada on camera control. Got a jam-packed show for you tonight with lots of new products, videos coming soon. And bonus, we got ahead of time questions, but your questions are also welcome. We'll read them at the end of the show. Mr. Lady Ada, let's kick it. Tell them the code. Tell them what's on tonight's show.
On tonight's show, the code is Feather RP. Make sure you have 2 R's in there. We will be celebrating the launch of the Feather, powered by Raspberry Pi, the RP 2350. Feather RP. 10% off a native store all the way up to 11:59 p.m. Eastern Time. User will lose it. Talk about some of our live shows, including Show and Tell, recap of Desk Lady 8, including the Great Search. We got JP's product pick of the week, time traveling look around the world, makers, hackers, artists, engineers, and more. We've got some factory footage. This week is a time lapse from the Lady Ada Lovelace mural we just painted. A couple 3D printing videos. Everyone's favorite segment, Eye on MPI, new product introduction this week. It is Infineon, brought to you by DigiKey. We got some top secret. We have like 7 top secret things. New products. We answer your questions. We collect them all throughout the week, and we also do live questions on the show in Discord, adafruit.it/discord, discord.gg/Adafruit, all that and more on, you guessed it, Ask an Engineer. All right, Lady Ada. So, look at these feathers everywhere.
From all the pets I've been eating.
Yeah, I know, right? So we have a discount code, and people get 10% off in the store. Feather RP is for the specific product that we just put in the store,
which we just
put them in.
Yeah,
so it's the Feather 2350, but you also get free stuff. What do they get?
If you order from the Adafruit.com shop, we'll get some free stuff. Of course, we also have some wonderful distributors, but we can give you freebies when you order from Adafruit. $99 or more, you will get a free PCB coaster with a gold Adafruit logo and 4 protective bumpers. I use mine every day to protect my iced tea. $149 or more orders get the KB2040. It's a Pro Micro pinout compatible microcontroller board with lots of GPIO, STEM QT, NeoPixel, and an RP2040 and USB-C. So it's great for making keyboard projects with a powerful QMK and KMK processor, or any other microcontroller project. $199 or more, free PS ground shipping in the continental United States. Yeah. And $299 or more, we're still giving away Circuit Playground Express, our favorite all-in-one dev board that has NeoPixels and speaker buzzer and buttons and sensors, infrared accelerometer. It runs Arduino or CircuitPython or code.org, CS Discoveries, or MakeCode, or kind of like a whole bunch of stuff. SAMD21, very popular chip.
Rust.
Although I'm thinking maybe of updating this to the RP20.
Oh, okay.
Yeah,
all
that's what we got.
Okay, so free stuff and of course the code. Okay, we have live shows all throughout the week. We do Show and Tell. We have Noah and Pedro's 3D Hangouts. We've got Ask an Engineer. We have JP shows. We have show and tell, which we just did a few moments ago. Thank you, JP, for hosting. I need to go watch it. I actually don't know what was on the show and tell. I glanced over to make sure.
Some synthesizer stuff.
Saw synth. I saw some like 3D rendering thing. I saw like, a
Trevor
robot.
talked about It's a Snake.
Yeah. So
About Whippersnapper.
come on by, check out the show and tell. It's every single week. And then on Sundays we do from the Disco Ladiata. Do you remember what you did on Disco Ladiata, including the Great Search?
I think I talked about some prototypes. I also showed up the ESP32P4 eval board.
Okay.
I have and some designs I've been working on. I'm trying to get back into
All right.
getting new products in the shop.
All right. So check it out. And then on
I did I2S DAC for the Great Search.
Tuesdays, we do JP's product pick of the week. Here is this week's highlight.
It is the CH334F mini 2-port USB hub. So I'm going to plug that in to my computer. And not only is my mouse working now, but you can see a new flash drive has shown up. It's got this secret. So you can see here, I can click on, upsettingly, Lars' top secret folder. What does Lars have in there? Originally, black cable is the mouse cable. Soldered the mouse wire directly to the port side of the upstream connection. So that's what goes to the computer. And then I have essentially two peripherals plugged in on the downstream side. One is the mouse, and then this is a thumb drive that I gutted. You can see it turns on the mouse, turns on the hub, turns on the thumb drive. Today it's the CH334F mini 2-port USB hub.
And don't forget JP's workshop, which is tomorrow. And then on Friday, deep dive with Scott, 2 p.m. Pacific, 5 p.m. Eastern. Okay, let's do some time travel. Last week, we talked about the 3 logos we're looking at for the floppy disk gallery. You know, part of the fun or issues when you talk to the internet is the dudes who you know, they can't have anything nice. So you know, the disks that are not floppy, that are you know, structurally not floppy, they're still called floppy disks. They're still called floppy disks. They're still called floppy disks, but you know, you can never, like, that's not going to work out. There's that one guy, it's not actually floppy. So anyways,
And I'm sure if you're getting
what?
I don't understand where this is coming from.
Well, because the bottom disk is actually floppy.
Oh, it's actually floppy. Okay.
It's actually floppy, but,
All right.
but some people can't hold 2 thoughts in their head. So you know, obviously the middle one, so these are the 2 that the people were gravitating towards. The middle one got the most votes.
Okay.
But you know, it's going to be like, but that's not actually a floppy. Yes, it is. It's what people refer to as a floppy disk.
It's a floppy disk.
Yeah, except for the
It's a 3.5.
yeah, except for, like, you know, okay. So you know, I'm not going to debate about is this actually called a floppy or not. So this is going to be probably the logo. I have a couple other things I'm going to do. Thanks everyone for voting. I did this on a bunch of different social networks and more. And I do like this one. I do like this other one. Yeah,
Nice.
there's a little tab at the top. That was just a design element that we were looking at. But you know, for the most part, overwhelmingly across all the places, this was the one that folks picked. So we're gonna go with this. So that's the winner. It's a floppy on the inside. We're all floppy on the inside. Okay. So yeah, congratulations. Second logo. Okay, let's do some Python on hardware. This week is going to be a little bit different. By different, I just mean that we're going to, you know, remind you to, of course, check out the newsletter. But we're going to play a video of, I think, the first time this new ESP32P4 has been running something like Circuit Python. We got one, and like within hours, you were
actually, I have to clarify. So Brian Whitman actually did the port, so he actually did get it working, and Scott just did some tweaks.
Okay, yeah. So this is the first like sign of life.
This is a certain first visual video, maybe.
Yeah. So, anyways, we're gonna have this written up in our newsletter. This happened, I think, earlier in the week. So we're gonna play the video, and kudos to Brian Whitman and then Scott for getting it over to us to check it out. So let's run the video. All right, Lady Ada, what's this?
Okay, so this is the ESP32P4 eval board that I got a couple days ago. This is featuring the new ESP32P4 dual core 400 megahertz RISC-V processor for Expressive. It's got the cool MIPI DSI and CSI connections on it, and Ethernet. And one thing we want to do is port CircuitPython to it. So I've got my computer connected through the USB UART because we're still working on getting the native USB working, but right now we're going through this CP2102 converter into the chip. And check this out. Scott got a basic build working. So if you zoom out just a teeny bit, you'll see this, and I can restart it. And then I can say, hello world. From ESP32P4. I'm using the online editor to save and then restart. And now it says this, and I can do print, I think os.system. Let's see. I'm not so used to using the editor. So this is a great way to test the editor. Oh, wait, hold on. I got to import. Import OS. We actually wrote this for particularly Expressive boards because sometimes they don't have native USB. So let's save and run. Oh, OS dot, you know what? I have to remember what it is. Actually, you know what I can do? I can go over here and there you go. I can do import OS and then OS dash, what was it called? Oh, maybe I don't have, maybe it's not OS, maybe it's something else. Oh, uname, that was it. There you go. ESP32P4, release 9.2 alpha, running on the eval board. So live, it's live. It's really working because I can't even take it anymore. Anyways, exciting. It's just like to see the first boot. I remember when we had the SAMD21 first boot CircuitPython. So this chip is going to be a beast. It has 16 megabytes or 32 megabytes of internal PS RAM. So it's going to be awesome for running CircuitPython. It's basically like a computer.
Cool.
Very exciting.
Okay, so if folks want to play around with that soon, I guess we'll have something for them, right?
There's actually a PR right now, and I think that there's artifacts in the PR in the CircuitPython repo, and they can just download from the attach. I mean, if you know kind of how to navigate GitHub, but you can get the artifact generated by the CI, and you can try it out.
So they could, if they're I saw people are getting these dev boards.
It's there, yeah. You can try.
So they can play around with it.
Play with it, yeah.
Okay, so we'll add more to the newsletter next week. Do check out the newsletter.
Very early.
Yeah, do check it out. That's like cutting edge stuff. I talked about this last week to 4,000 stars on GitHub. Thanks so much. Some of the stuff that's going on with the RP 2040.
2350.
Sorry, yeah, I'm just gonna get that messed up for like 45 more times. 2350. And then you can check out all the projects that we have. It is chock full of Python, running on hardware projects, and more. Join about 11,000 plus people.
Oh, I like that HID, man. That thing was cool. This is a it lets you use a USB keyboard with a PS2.
All right, I sent you that
device. Yeah,
I said that was a good idea. Yeah, it was on Hackster. Good project. So anywho, head over to Adafruit Daily. We send this out every single week. Spam free. We do doing tracking. You can look at it on GitHub. You can get it as RSS. You can look at it as a blog post. All the different ways that you want. Okay, some open source hardware news and more. And then I have an announcement from Ashwa that just came out today. So sort of breaking news. First up, Wired. So I pay for Wired. So I guess it's okay that I can talk about this article. It's behind the paywall.
yeah.
But I did a blog post about it. And it was about everyday robotics. And it was about Google, who bought up all these robotic companies over the past like 8 years. And they just like ended it all. Basically, the person was in charge of all of it. And I was actually surprised that like it's very insidery baseball, very tell-all-ish. And I was kind of surprised about the level of details and more that they were willing to talk about running a robotics effort inside of Google. So this was how to get everyday robots that would interact with humans and be in human environments, very complex environments. The end result was maybe this can't ever be venture funded. Maybe it can't be something that investors have to be patient with. And this is really important, so we should do something. So as usual, the reason I'm putting this in my open source hardware section is so that's 8 years worth of work. Could they put it patent free? Could they put it under open source hardware licenses? Could they do something so the next round of people with Google budgets or even not Google budgets not have to start and build everything from zero? Because I've seen like 100 robot startups and it's always the same. It's like, look, we figured out power and an arm and now we can pick up the thing. Now we got vision. Oh, we ran out of money.
Yeah.
Over and over. You probably saw a bunch of stuff in Media Lab over and over. And then it goes on to be a business, and then the business eventually can't keep up with the funding that's needed to do a robotics company, and then it goes bust.
Yeah. That's why Kuka's doing really good.
By what?
Kuka.
Yeah.
They should buy an arm. They figured they got to the end.
Yeah, they're like, don't.
Yeah.
Okay. So
But it's like really expensive.
yeah. So anyways, you can check out the article more. I link to it on a blog post. And I also pulled some quotes about, their view on funding and robotics and more. Kind of interesting. We shall see who the next giant megacorp who wants to do human robots are. Maybe it'll be Tesla, maybe it'll be Amazon. We'll see. A lot of these things are also done in secrecy, so it's interesting to see the photographs behind the scenes there too. Okay, OSHWA, Open Source Hardware Association, Open Hardware Association, announced Open Hardware Month. Open Hardware Month is in October.
Yay.
They're going to have a 24-hour live stream membership drive October 2nd to 3rd, 8 a.m. to 8 a.m. It'll feature talks and projects from the wonderful creators across the open source spectrum. Be sure to mark your calendars, drop in, certify, and become a member in October to celebrate. And then they also announced today that the Open Hardware Summit is going to be in Edinburgh, Scotland. So that's coming up in 2025. I think it's in May.
Fun.
Yeah. Okay. Next up, we're going to do Adafruit Learning System. Lady Ada, what is on the big board this week on Adafruit Learning System?
Okay. New guides. So let's see. Scroll down a little bit. Okay. So I think last week we did the Crayola candle and then the ESP 32 C6 feather guide, I think went live last week. And then we've got new this week, the CH32 V203 Cutie Pie. We finally got the board support package and TinyUSB stuff merged into the board support package that's run by WCH. So it's much easier now to install and use this with Arduino. It's a cool, very low cost ARM core chip. If you've been playing with the CH V003 or the CH55 something, whatever, check out this one. It has like built-in USB bootloader and it has like Arduino support and it's the same price. It's like, and it has 200K of flash you can use for storing your program memory. So it's actually like a pretty good processor. I'm gonna do some more stuff with that. We recently got ESP32S3 BLE support working in CircuitPython. It was being a little funky. Scott fixed it. And so here's a project that shows how to use a BLE to RS-232 gateway for controlling a, in this case, it was a monitor. But if you have anything else that's controllable by RS-232, you can now make a little bridge that goes to BLE. So you can skip like 4 generations of protocols. Just go right over USB and right over PS2 and straight to, Bluetooth Classic and straight to BLE. 4, to control your retro devices. Noah Pedro did this project, the LED noodle lamp. We have a video. And Tim C wrote up a project, a good demo of using Async IO to have a Simon Says button LED board. Like I said, a good demo of LEDs, buttons, and asynchronous reading and communication. So check that out. A good tutorial. People have always been asking us for async projects.
All right, and we have a little video from the I think it says. I'll play just a few seconds of it.
Hello everyone. This video is a peek at my latest project, a game called Blinka Says that is inspired by Simon and built into a cardboard box. It uses an Adafruit Feather ESP32S3 TFT, but the S2 variety would work as well. The colorful arcade buttons with LEDs.
Okay, and then Adafruit Playground. If you just go to Adafruit-Playground, you can also click it from Learn. We have a new little explainer up at the top because people are like,
I like this orrery.
Yeah, and we
separate for orreries.
We have a ton of new projects. So do check out the how to text and more, and then also of course check out some of the new projects. Let's do some factory footage. This week it is a mural of our Ada Lovelace art that's in our factory. that's the factory footage for this week. Let's do some 3D printing. Alrighty, we're going to jump right in. We're going to do the project from Noah and Pedro, and then a speed up, and then we're going to go right into Ion MPI. Take it away, Noah and Pedro.
You can build a Victorian-era inspired lamp using an LED noodle and 3D printed parts. This features a 12-volt LED noodle that's shaped in a zigzag pattern that wraps around a transparent 3D printed core. A glass dome fits over the LED, giving this a unique aesthetic. Mounted inside the base is a 3D printed switch that's inspired by the Hubble household light switch. The HUSB 238 breakout is a power delivery board that lets you power devices using USB-C wall adapters with multiple voltages. This features the HUSB 238 chip, Stemma QT for I2C control, screw block terminals, and dip switches so you can easily select your preferred voltage output. Enabling the 12-volt selectable output allows us to easily power this 12-volt LED noodle using a USB PD wall adapter. Just solder up a 100 ohm resistor in line with either the ground or voltage wire to reduce the brightness, and you're ready to glow. The LED noodle is pressed into the built-in channels in the 3D printed core and loops around, covering all sides of the cylinder. The enclosure design is open and free to download. Most of the parts snap fit together, and it's got plenty of space for additional components or features. We hope this inspires you to check out the HUSB 238 power delivery board for powering your next project.
Don't forget the code is Feather RP. Let's do some Ion MPI.
On MPI.
Ion MPI brought to you by DigiKey and Adafruit. Thanks, DigiKey. This week is Infineon. Lady Ada, what is the new product introduction of the week this week?
Okay, this week we're looking at Infineon's Easy PD series of chips. This is a chip and an eval board called the BCR Plus. To be honest, I can't remember the exact part number. It's like CY something something. Or maybe at the end it'll pop up because I linked to the chip itself. This is a chip that is pre-programmed with firmware that makes it a drop-in replacement for when you want to replace a DC barrel connector with USB Type-C. It will request a voltage from 5 to 20 volts for you. You don't have to do any firmware. You don't have to do any configuration. You don't have to do any I2C stuff. It just kind of magically works, which is cool. Because for like decades, people have been using barrel jack plugs. I'm sure you have like a box of these at home. Like every device has a slightly different voltage and a slightly different connector. These wall warts usually come in fixed voltages, although here we have one that has flexible voltages. There's a little red switch you can flick between 3 and 12 volts. But the problem is that there's like so many different voltages and tips. Like we have a tip set, and you can have positive or negative polarity. It's like literally there's hundreds of different combinations of voltages, polarities, and connectors. And so as an engineer, if you're designing a product that takes in a DC barrel jack, you want to use something that's common off the shelf, but you also don't want to overpay, but also you want to make sure it doesn't get confused with other stuff, but also you want to make sure that it doesn't get damaged if somebody plugs in a slightly wrong thing. Which is why you end up with like a drawer full of different power adapters. And because the power adapter is made by different companies usually than the product, it doesn't say what it goes to. It's like I have a NiCad or nickel metal hard drive battery charger. It needs 3 volts, 4 amps or whatever. And like the battery charger uses a DC plug, and the DC plug doesn't say anywhere what it is. I just have to kind of like magically guess and know. And so this is a common problem for engineers and users. Also, if people lose the adapter or they move to another country, and so they need a new adapter, or they break the adapter, or the plug gets broken. Now you have to supply them a matching adapter, which could be, you know, again, non-trivial if you're not using a standard 5-volt or 9-volt adapter. Totally sucks. So the solution is, well, I have N standards. We can have N+1 standards. Now we have USB PD, which is power delivery over USB-C, and you usually have an adapter that looks something like this. This is like a laptop or iPad charger or whatever. It's a generic USB-C adapter. And you can see the output. It can give you 5, 9, 12, 15, or 12 volts. I do have to specify it's or. You only get one voltage out, but you can choose from any of these. And if your product can use any of these voltages, you can just skip over having a DC barrel connector and use a USB Type-C. The only problem is if you're using USB-C and if you want 5 volts out, which is kind of like the standard, you know, held over from micro B, mini B, and USB-A, it's really easy to configure USB-C power delivery for 5 volts. You just put two 5.1K resistors on the two CC lines and you're done. You don't have to do any other configuration or setup. You'll automatically get 5 volts, 1 amp, or 2 amps. But what if you want 9 volts or 12 volts? Well, that's where this EasyPD BCR Plus comes in. So it's a pretty cool chip because it's got, you know, this ARM Cortex inside from Cypress / Infineon, and it can do all the detection and management, and it has non-volatile memory, so you can actually pre-program it and configure it for a particular voltage and current. And then like it's fixed in hardware. You don't have to have any external components. Usage is pretty simple. It has, you know, CC1, CC2 pins, power and ground, and then it can control a FET or multiple FETs if you want to like have total separation between input and output. Fault detection, and of course customizable firmware if necessary. It is still an ARM Core Cortex M0 inside. So here's like a usage diagram. This one has like extra FETs, I think, because they're doing like full separation between input and output, but I think you can get away with just a single pass FET. And this also has the D+ D- lines for back compatible with like there was previous data line configurable power adapters for like Apple devices and such. You can connect an external I2C device to configure it. Usually you'll have to do that once because it saves the settings in non-volatile memory. But also I guess you could probably configure it on the fly. And at the bottom, you can see the sync and voltage settings. What's kind of cool about this chip, the CPYD 3176, is that you can set both a VBus min and VBus max. So if you have something that can run from 9 or 12 volts, you can set that up to say like, or 9 to 15. You can say, here's the 2 voltage ranges I can accept. Otherwise, you know, don't underpower me because I'll have an undervoltage problem. And in the data sheet, they tell you, you know, all the voltages that you can configure it from 5 to 20, which are the standard voltages, and also the amount of current you want. So this chip can request up to 5 amps. Not all USB PD chips can do 5 amps. A lot of them actually top out at 2 because they don't have the full like eMark firmware capability. They don't have like the full negotiation. Only thing is if you're doing 5 amps, just like make sure that your cable can handle the 5 amps because it's you'll need like thick wires so you don't have too much voltage drop. Pardon me. As mentioned, there's also legacy charging support. If you don't want legacy charging, just disconnect D- and D+. It's not necessary. It's only for this like Apple QCE, whatever charging stuff. USB PD is what we recommend. Pardon me. Is it on Cortex with EEPROM inside? So you can, you know, again, configure it over I2C. You can also just burn new firmware into it. If you need that, it wasn't linked directly from the data sheet, but you probably just have to contact Infineon and they'll make the firmware for you, give you the binary, and you can burn it yourself, or they'll give you the configuration over I2C for exactly what you want. What I would recommend is picking up the CY4535 Easy PD eval board, which is kind of everything you want all in one with like tons of test points. So you can, if you're like, will this actually work for my product or design to replace the DC barrel jack? It's really, really easy to use. I've actually got one here. Maybe we can go to the overhead real fast. I'll just show it. So you have this like switch here that you can select different voltages. Like I have it set to 3. This is connected to USB-C. This part is like an external interface if you want to do I2C, USB to I2C conversion. The actual PD stuff is only on this side. And then this is the pass FET. There's some passives, lots of test points. And then if I plug in my multimeter, okay, and I want to measure the, okay, can measure the voltage on the terminal blocks. Let's get the right, this is negative, and this is positive. You'll see I get 12 volts out, and then I can unplug, and I just flipped this switch over to number 4, and then I plug it in again. And then this time I measure it, and it's 15. So I have it plugged into my laptop power adapter, which can handle up to 20 volts. So, flick it again. Now it's on setting number 5. Plug it in, measure, and I get 20 volts out. So yeah, that easy. Kind of trivial. No firmware to write, no registers to wrangle, no drivers required. This is just setting the resistor divider. That's it. So pretty easy. So yeah, this is, I think it's like it's like $30 or something, or for $40 from DigiKey. It's in stock as well. So yeah, I mean, I just kind of went through this, but you pick which output you want. You plug in a valid USB power delivery. Don't forget, it actually has to have the output voltage. If it doesn't supply 20 volts, you can't get 20 volts out of it. And you measure the output, and there you go. You get 5, 9, 12, 15, or 20 volts. So check out this chip.
In stock, and also
And it's inexpensive. It's only $1, which
Yeah.
is a really it's exactly kind of like the right price. And you get, guaranteed supply from DigiKey, which is why we're.
So here's a question during this segment. Here it is. Can this chip only pass voltage if it's the one requested, not below it? I've seen chips that just pass whatever they get as long as it's below or equal to what's requested. I don't feel that's safe. Some devices might break if it's below the rated voltage, maybe not on computers that use linear regulators, but some switching power supply units actually won't work and literally pass higher voltage if the input is not high enough, which is dangerous. I'm thinking about making such an adapter for the M05, which needs.
Yeah, I think that's the VN min and VN max. I think you can set it so you tell it like, if you can't give me 15 volts, don't give me 12. Which you're right. It's not uncommon for USB PD sinks to sort of just like go the next lowest. But yeah, the next lowest may actually be not good for your
You can
device.
tell them, don't do it.
Yeah, don't do it.
Okay. That is this week's INPI.
Okay.
Good question.
I on MPI.
Okay, don't forget to go guys feather RP. We're gonna go right into new products. Ready?
Yep. New.
What's new?
Okay, new. We had a request for a right angle USB extender. That's what this is. It it attaches to a. Actually, can you go back one? Okay. These 2 ears attached to an enclosure. You drill or cut a rectangular hole, and then the cable comes out right angle wise, and then on the other end, a matching USB Type A. Pretty simple. Just passes everything through. Good for many uses. I think it's about 30 centimeters long. We also have a straight through version, not right angle style.
Look it up.
Next up, we have 3 different lengths of 22 pin 0.5 millimeter pitch AB flex cables. You can use it with the Raspberry Pi 5. We're also going to be using and selling these for use with the Raspberry Pi RP2350 boards that we have with an HSTX connector because it's 22 pins. But the Raspberry Pi 5 uses this cable for DSI and CSI, so it can also be used for that. It's good for kind of any kind of high speed signal. I think I have 5, 10, and 20 centimeters long.
Next up.
Next up, we also have a request for SMT SD cards in larger sizes. We've already stocked the 512 megabyte. Now we have 2 and 4 gigabyte versions. Just, a slightly variant chip. It's a 16 gigabit or 32 gigabit. Basically, this acts like a micro SD card, but it's vibration proof. The only thing is, of course, you can't plug this into USB. So it's good if you have a device like CircuitPython or Arduino with TV USB where you're having it act like a mass storage device, or where you're okay with it not being physically removable and pluggable into a USB dongle or card reader. Still, there's some cases where it's useful, especially like I said, I've heard of people who are like, hey, I have a rocket project or a robot project, and I don't want there to be any risk of the SD card popping loose or shaking loose from the connector. This would be, hard mounted in.
That's cool. So on the show tonight, besides you, Lady Ada, our customers, our community, our team at Adafruit who make things go is the Feather powered by the Raspberry Pi 2350. Lady Ada,
Yeah,
it's here.
it's here. We just had to iron out last bugs. We've got the chips. We've got everything running. We put in our first 100 boards. We're going to get more made. Got more PCBs on order. Just wanted to make sure there was nothing wrong with the first 100. But you can pick them up in the shop if you're watching this live. If you're not watching it live, it still might be in stock.
Who knows?
So it's got the RP2350. It's a dual core ARM or RISC-V core running at 150 megahertz. Because it's an M33 and it's got a floating point unit, it's about twice as fast as the RP2040. At least when we've been running CircuitPython code, it's kind of what we've observed. For RAM, it's got twice as much RAM, about 520K instead of 260K. There's also 8K of one-time programmable memory, like for configuration or crypto keys or whatnot. It's also got Trust Zone for secure boot, something that the RP2040 didn't have. People asked for. Apparently, it's got better low power support, low power sleep state power usage, but that's still under development. So I don't know if there's software available for testing it yet. Like I said, twice as much RAM, optional PS RAM. So if you look at the top of the board, in addition to the QSPI flash memory, we put 8 megs on there. There's also an 8 SOIC spot for soldering on PS RAM. If you'd like, PS RAM is usually available in 2 or 8 megabytes. It's a little, expensive, so we didn't offer it by default. But if there's projects, can you refresh? Should be. Oh, maybe they're
already gone.
They're already gone. Hold on.
Could be. Sorry, a little live check right now.
Well, I can't actually.
Yeah, tell you what. We're gonna play a couple of videos in the top secret section.
Yeah.
And we're gonna check. We may have sold out.
I really checked. It said
we may have sold
let
out.
me check. Maybe I didn't uncheck something.
Oh, but why don't we do it during the top secret section?
Did you do top secret?
Yeah.
Okay.
Okay, so keep going. Yeah.
Okay. It'll be in the store in like 2 minutes.
Or we sold out.
Or we sold out. I also have a debug port that got the request for that. Thankfully, since the RP2350 has come out, there's now the Pico Probe connector, which is JST3SH. You can use it with the Pico Probe board that they sell. It's still got the battery charging, and you can run off a battery and it charges over USB-C. You can now cut a jumper on the back if you want to disable the charging. So some people ask like, oh, I want to run it off of a non-rechargeable battery. You can disable charging. And then USB-C for bootloading and code. And can run Arduino. There's now Arduino support, CircuitPython support, MicroPython support, Pico SDK. And the last cool thing is the HSTX connector on the end. So there's a new peripheral on the RP2350 that allows it to drive DVI displays without using PIO or overclocking. So we made a little connector that brings out all of those
That's cool.
high-speed transmission plus I2C. And we'll have some add-on boards that let you do DVI output.
Okay, that's new products. And then I'm gonna bounce out for a second, then all right, so here's what we're gonna do. We're
Yeah.
going to do top secret, and while I'm playing 2 videos, Lady is gonna check and see
I think I can
if
look at my phone.
we put all of them in stock or some of
I
them,
think I
or if
can-
they were sold out.
I
We'll
think I can
see.
check off a
We'll
box or
see.
something.
We'll see. We'll see.
There you go. You'll have a chance.
Either way, hit refresh on the product, or I'll tell you in just a few minutes. Let's do some top secret.
Okay, lady, what's this?
Okay, this is our first board with the RP2350 chip, the new dual-core M33 from Raspberry Pi. This is a feather version. I got 8 megs of flash and this cool HSTX connector, so you can do high-speed display work. We usually start with a feather, and then we'll do a Metro, and Itsy Bitsy, a Cutie Pie, but we start with the feather because it's kind of our tried and true. So here's my tester board for it. I'm going to plug in this feather, and then I have a HSTX flex connector over here. I'm going to reboot. The way this works is this RP2040 Pico loads the RP2350 as a USB key and then does a GPIO test. It tests all the pogo pins and the HSTX connector. And finally, it does a little NeoPixel swirl. So this is good. This tester's ready to go. Thanks to Scott for helping me spot some clocking issues. I'm going to get these in the store next week.
Okay,
Very exciting.
great. And this is from the desk of Lady Ada here. Gonna show we're shutting down for the end of day, but this is the factory with our new little mural that we got. Yay! All right, Lady Ada, what's this?
Ooh, I just got some new stuff in the mail today. This is the ESP32 P4 eval board. This is a really cool chip. This chip doesn't have Wi-Fi or Bluetooth, but it does have a lot of memory, a lot of power. It's RISC-V. It's got high-speed USB on the go. It looks like it has Ethernet, if you just add a phi at the end maybe. It uses this ESP32, I think C5 for external Wi-Fi. It's kind of got this like Raspberry Pi-ish layout and pinout. And then MIPI in and out, so CSI and DSI. Super powerful chip. Just got this board in, and I'm getting it also comes with like, camera accessories and display accessories and stuff. And then I also got 100 chips, which is exciting. So I can actually start developing some hardware with this. This is a cut tape of ESP32 P4. This is the 16 meg version. 32 meg version, they're still giving me some samples soon, but I can start with this because they're pin compatible. So looking forward to making some cool designs, a feather, a Metro. What do you want me to, what do you want to see me do with this?
I'm sure some guy on Twitter is going to tell you.
That's right.
Okay, good.
Greets, everybody.
Okay, some more top secret. Lady, what's this?
This is a breakout for the U-Blox Max 8, which is a pretty nice all-in-one GPS unit. Got some samples in, so designed to break out with a battery on the back. What's cool about this is it has both I2C and UART, and like U-Blox makes some of the best GPS units.
Next up.
Getting back to some old designs that during the part shortage I couldn't get parts for. This is a 4-channel I2S microphone input, so you can take 4 analog line level or electret microphone inputs, and then without needing a lot of effort, you can output them to I2S. So it's good for like, I think I saw this in like a Echo Dot or something that's used for their spatial audio.
It's fun to tear down Amazon stuff and figure out what parts they use and then make a cool product for all of you. Next up.
This is a PDM mic. We covered a I2S version of this mic on the Great Search. But this PDM mic is kind of cool because it has a wake output. So it can, instead of having to listen for audio levels at all times, it'll toggle a pin when it hears some audio, which means like your low power project can wake up immediately and start listening for wake words.
Okay, next up.
This is another I2S microphone, but this one doesn't require I2C configuration. It actually does it all using GPIOs for like setting up the pinout, which I kind of like because I hate writing I2S drivers, and especially on stuff like Linux, it's kind of a pain to get drivers and stuff.
Last top secret of the week.
And this one is just stereo version of the same.
Okie dokie, that is our top secret for the week. Code's feather. That you know why now.
Oh, the feathers.
So we're gonna do questions.
Sure.
And we have the ones lined up. So
Okay.
here we go.
Questions.
Okay, first one. I'm going to do this one. What is the purpose of making CircuitPython a derivative of MicroPython? Or to rephrase, what did you want to do that you couldn't do with MicroPython? Glad you asked. So first up, we have an entire hour-long keynote that Lady Ada did for LinuxConf. MicroPython's open source, CircuitPython's open source, and we talked about this at LinuxConf AU. You can check it out, all 167 slides. You can check out CircuitPython.org, where we have kind of the high-level stuff, quick and easy, beginner-friendly, easy code updates, file storage, USB serial, console and REPL, strong hardware support. Of course, for someone like us, we needed to cover lots and lots of different chips, more than just the one that MicroPython supported. And you can go to CircuitPython.org and check out our entire page devoted to this. And you can see where we talk about this, because this is a frequently asked question. And for us, we are the biggest financial supporter of MicroPython, unless someone tells us different. You can check our support at our fund drive that we do, and you can check out the GitHub repo for CircuitPython, and you can learn about the differences between the two there. Basically, we needed lots of hardware support, and MicroPython was very specific with the support that it offered, and we wanted to do something for beginners. So there you go. Next up, this is from Dad. I don't think it's my dad. Can we submit floppy disks for possible addition into the gallery? Yes, I have some old ones from the late 1980s that are fun. Yeah, we'll make it easy for people to do that. Next up, we showed a top secret that was coming soon, and someone wanted to know, cool, any similar, but for output. So this is for input.
This is something I could cover on the Great Search. I don't know of a quad speaker output, but one thing I definitely know about, the TI I2S stuff is usually if they have something that's input, they have a version that's output.
Yeah. Okay, next up. Is there a good DAC partner with volume control and headphone amp you recommend? I was using the numbers, but was obsoleted. Close I could find with the Nuvoton NAU88C22.
I don't know one offhand, but I've used the WM with like 8960 on the Braincraft hat, and that has volume control. It has I2S, which again, I'm not a huge fan of I2C headphone control, but it definitely will work. I'll say one thing is, if you were going to use the TLV 320 AIC and they don't have that chip anymore, you can just contact TI. They probably have something similar. And they're kind of like constantly like renaming their chips, but they don't tend to discontinue something like forever and ever. Usually there's something that can replace it.
Okay. How easy to convert MIPI to DVI?
It really depends on what's driving the MIPI. It's like if it's something that you can configure to output DVI, not so bad. But MIPI is a much more complicated protocol than DVI, so it's like you have to turn off a bunch of stuff.
Okay. Say you want to make a DVI trail camera based off motion sensing. How do you optimize for quick reaction time to activity and low standby power draw?
I mean, it's really hard, right? Which is why most people can't do it. The best thing I can say is, hopefully your animals are slow. Or you have to have a system that boots up very quickly. So you want to optimize for something that will come online. I know that there's some fast booting variations for like the Raspberry Pi. So maybe that could work for you. Like you'll need something that comes up within like a second or two, right?
All right. Our breakout boards have capacitors liberally placed throughout. For a non-EE novice PCB designer, is there a good rule of thumb for when and how to sprinkle caps on a board?
We usually check out the data sheet for the chips you're using because they'll tell you, like for a regulator, how much capacitance you need in the input and output, they'll tell you. Although I tend to start with a 10 microfarad, 1 microfarad, 0.1 microfarad. Every chip, if it's just like a simple logic chip or doesn't draw a lot of current, I'll just put 0.1 microfarad on every VDD or power line. And you want to have it close to the power line and then a nice big ground plane. If it's drawing a little bit more current, I might give it, like an ESP32, which needs a lot of current. there's only one power pin. So instead of having like 0.1 microfarad, you'll put 4 10 microfarads all in parallel. So you get really low ESR all next to the power pin. So nothing is just, try a certain amount. And if you're making a lot of it, you'll quickly find out that you're having power issues. But, for, most things, a 10 microfarad and 0.1 is good enough.
Okay. Upgrading my longtime beach cruiser bicycle to an electric motor. It has a beefy 24-volt battery and connects a decent quality motor control board. But when I connect the battery and MCB, it makes a loudish snap noise. What could cause that? And is there an easy fix?
Um,
You need a capacitor.
No, I mean it sounds like it's arcing, which will eventually corrode the battery or the motor control contacts. Make sure it's off the battery. Yeah, sorry, make sure that the motor controller is off, and then it sounds like there could be some input capacitance that's just like it when it connects, like a lot of current goes through. So I'll contact the motor control maker, the motor control board, and ask them like, is there a way to have it take a little bit longer to charge up rather than like bursting
Zork.
like 10 amps or something.
Okay. And this is almost the last one from the questions. Might be searching for wrong terms, but anyone built either a microcontroller based or small pi based audio delay unit like audio input, buffer it from anywhere between 20 to 2000 milliseconds and output. It seems like a simple use case, but haven't seen a project.
You don't see a lot of audio delay lines. Some people use like specialty chips. I know that Open Music Labs made a microcontroller delay line. One of the challenges is that you have to be very, very fast. You need a lot of memory. Like if you do the math on like how much RAM you need to buffer 2 milliseconds of whatever 44 kilohertz audio, like it's more RAM than most chips have. Although an ESP32 might have enough PSRAM, and RP2350 might have enough PSRAM if you started on an additional RAM chip. But like a couple hundred K is not going to do it for you.
Project to do.
Yeah, you could do it. I think an RP2350 with some PSRAM could probably do it.
And then I saw this comment on Hackaday because they had a question that says, what's next? And someone said, we need an open source replacement for all the IoT cloud crap that's actually beautiful, intuitive, and can be used by non-technical users. And someone said, Adafruit IO is the next best thing. Really like that after fluffing around with all the alternatives. Maybe my trust is misplaced, but I trust those guys with my data way more than big tech co's. That's a tough audience over there on Hackaday, and so we appreciate that for the answer to what's next. So let's go to the rest of the questions that we have on our computer here.
Yeah.
And let's speed round these so we can get you out of here. This was an earlier question. The person was looking for a 120-degree lens with autofocus that would work with the Memento camera.
It should work. We don't sell it separately, but you can just peel it off a breakout. And try it. I mean,
someone suggested a clip-on for like the mobile phones. That should work.
Yeah, that would work too. I mean, I think we went with the non-distortive lens on purpose.
Okay. How would someone use a multiple WeChuck breakout with 2 Wii Pro controllers on one HID board and have the 2 controllers control 2 separate emulated joystick controllers with each Wii controllers?
You can't. I don't think you can have 2. You can't have one HID device mimic 2 joysticks. You have to have 2 devices.
Okay. Can you suggest a QC30 charging module?
I can suggest a USB power delivery, which is, I think, more modern than QC. Check out the EasyPD I just covered with Infineon. Like that'll do the job.
That's a good timing. Have you found any USB batteries that support the 5-volt 5-amp desired by the Raspberry Pi 5?
I haven't tried running it. I'm sure somebody on the Raspberry Pi forums has found something.
Okay. Someone wants a Circuit Python or Arduino bootloader compatible board made with the ATU25 6L3U, 51 GPIO, 36 PWM, 15 possible SPI, 12 DMA channels, and more.
You can post an issue in CircuitPython or in MicroPython and see if anyone wants to do it. I haven't heard of anyone else interested in that chip, so you might be waiting a long time if you're not willing to do it yourself.
All right, and last question. The new RP2350 has an option to cut the charging jumper to use lithium batteries. How well does RP2350 go into sleep mode with the Arduino? Would an ESP variant be better for long duration on batteries?
There's not been, I think, a release of the deep sleep code yet. I think we're still waiting on that. So right now, if you need deep sleep, I would say an ESP32 is gonna, we know it works. You can get down to like 20 to 50 microamperes.
Okay. Sorry, one just snuck in, but I don't know the answer to this, and I don't think anyone does yet. The RP2350 trusted zone, using the feature to keep your code a secret that can only be written once. There's not a lot about trusted zone online yet. I don't know anything about it.
Yeah, it's called Trust Zone, and I believe it's not that it encrypts. It's not encrypted firmware. It just is signed firmware. So the firmware can't be run on a separate chip. Like you can't take that firmware and then run on another RP2350. It's like keyed to that chip. You can Google for Trust Zone. I'm pretty sure the ARM consortium has published tutorials about it though.
If you find a lot of good information, total MK, let us know because we'll do a post. Because I couldn't when it came out, I looked around real fast, but that's when it first came out, so I didn't.
Yeah.
I was like, that's interesting. Okay.
And also at DEF CON, they did a presentation about it, so
Yeah.
you can see if the DEF CON presentation's been published.
Them's our questions
Okay, great.
for the night. Thank you
Thanks,
so much, everybody. Oops.
Questions.
Everything's. I got to get out of here. Okay, so thank you so much, everybody, for the views and coming by. A special thanks to our team, our community, our customers. Feather RP is the code. We still have some Feather RP 2350s left. Get them while you can.
They're like 60.
Yeah, we'll see. You know, when 75 left. So
Okay, I'm gonna notify some subscribers. So
yeah, we'll do that right now. So they'll be gone like as soon as we get off this
Yeah.
computer. This has been an Adafruit production. Thank you so much, everybody. Here is your moment of Zener.
Thanks, everybody.